You of course know that the Earth is bathed in sunlight every day. Every day we flicker different light sources on and off, mechanically, without even thinking about it. But imagine that one day you casually flicker the lights off, fall asleep, and wake up in a completely different era. Let's see how it happened and what it has to do with light. Quantum physics is quite crazy. Classical physics is like a movie projected from start to finish, while the quantum world is like having an ability to take the remote control and manipulate scenes you're watching. Fascinating and mysterious. Let's say you have a regular light switch that can be either on or off. That's like a regular bit in computers, which can be in one of two states, 0 or 1. But in quantum computers, there's a special kind of switch, a switch called a qubit. Unlike the regular bits, a qubit can exist in multiple states at the same time. It can be both 0, 1, and all things in between, like having lights on and off simultaneously. Yeah, our universe has some weird rules. This mysterious property, called superposition, allowed us to do something incredible recently, to reverse time back. At least in a tiny experiment with quantum computers. It's the autumn of 2022. Two groups of scientists, one from Oxford and the other from Vienna, decided to conduct a weird experiment. They played around with a quantum computer to create a program that reverses time. They took a tiny electron and tried to make it go backward for a time for just a fraction of a second. It would be like breaking a billiard ball triangle, where the balls go from order to chaos and then magically reverse. But don't get too excited about time travel yet. Unfortunately, we're not sure if it's possible to recreate it in real life. The scientists cracked some numbers and found out that if we observe 10 billion localized electrons every second for the entire age of the universe, we'd only see something like this happen once. And it would only take the electron back a tiny fraction of a second. So they didn't invent a time machine. They just managed to create this simulation in quantum computers. There's another catch too. The larger the simulation, the more complex and less accurate it becomes. In our experiment, we only used one qubit, and we managed to reverse time. In a 2-qubit setup, scientists could reverse time only in 85% of cases. And in a 3-qubit setup, it dropped to 50% with more errors. If we keep adding more qubits, we won't be able to pull this off at all. Plus, the success depends on the amount of information the system can store. For example, teleporting a person would be almost impossible because humans have so much information inside them. So, unfortunately, no time machine so far. But there are some possible uses of this discovery. Reversing qubit states in a quantum computer can help correct errors during development, sort of like a little Control-Z in real life. So, it was a tiny step to more exciting discoveries in the future. For example, recently they demonstrated another crazy little thing: send light itself back in time. Now, light isn't mere luminary. It has superpowers that we can't even imagine. The ancient Greeks believed that our eyes emitted visionary beams. Sir Isaac Newton proved them wrong hundreds of years later when he conducted his experiments with prisms. The prism broke the pure white light into a beautiful palette, and that's how we found out that light actually consists of tons of different colors. Many years later, scientists learned even more, that light is a wave. And even later, in the 20th century, we discovered the final paradox, that it's both a wave and a particle, a dual existence in one photon. And the more we learn about light, the more crazy things we find. In 2016, scientists managed to freeze the light in time. They put photons, the tiniest light particles, in ultra-cold atomic clouds. Then they managed to stop it, again, for just a moment. But the fact that it's even possible is already incredible. Then scientists got even bolder. They decided to try not only to freeze the light, but to move its direction in time. They took a special crystal and passed a photon through it, thus initiating the so-called quantum time reversal. As a result, the photon started moving into both the future and past at the same time. The science magic behind this involves two quantum principles: superposition and quantum symmetry. We already mentioned the first one. It allows tiny particles to exist in multiple states at once. Now, the second principle says that even if you flip particles around like a mirror, they'll still follow the same laws. Combining this, scientists crafted a photon that defied the usual forward march of time. But again, it's nothing super fancy yet. This time flip only works for specific particles, not entire humans. And even if it did work for us, rewinding a person even for a second would take a super long time and a lot of energy. But the fact that we can change the light's speed and make it change directions is already amazing. And scientists already see some possible applications to this. For example, Harvard researchers suggest a cool way for spacecraft to zip through space at the speed of light, by hitching a ride on supernovas. Usually, traveling to other stars takes an insane amount of energy, but these scientists have a wild idea. They think that spaceships could use natural events like hypervelocity stars and meteors zooming from supernovas to reach super-fast speeds. It's kind of similar to how sailing ships catch the wind. Advanced civilizations could use these energy bursts to speed up their spacecraft. Imagine a cool spacecraft with solar or magnetic sails harnessing the power of a supernova boom. These sails could use the pressure of the sun's radiation to work, so that we wouldn't need any traditional engines or fuel. Plus, these sails concepts are much lighter and cheaper to launch into space compared to regular spacecraft. The team is already working on a light sail accelerated by lasers to reach 20% of the speed of light. It might not sound like a lot, but it's actually an insane speed. Their dream is to help humanity make a swift journey to Alpha Centauri in just 2 decades. Isn't it amazing how many things we can do with light, and not just in our imagination? Let's go to more practical achievements. Recently, a Canadian camouflage company called Hyperstealth Biotechnology Corporation has crafted an actual invisibility cloak. The wizardly cloak doesn't need any power source, is as thin as paper, and won't break the bank. Hyperstealth envisions a world where this material can cloak people, vehicles, ships, spacecraft, and even entire buildings. It's still in a prototype phase, but it already works pretty well. They name this incredible technology quantum stealth. It bends light in a way that can make objects disappear from sight. It can render objects nearly invisible, not only in the visible spectrum, but also in ultraviolet, infrared, shortwave infrared, and it even throws in thermal spectrum blocking for good measure. The technology works thanks to the lenticular lens, a corrugated sheet with outward curving lenses. When stacked in a specific way, these lenses refract light at various angles, creating spots that block light and conceal the object behind the material. Unfortunately, it doesn't give you a full invisibility effect, but maybe someday we'll achieve it, if we keep working on it. If you hide behind it, it will look like a little dirty or blurred glass, but you won't be visible. If you put this veil in front of your body, you'll look like a floating head. Scientific progress is in full swing. Maybe one day we'll be able to reverse time not only for little light particles, but for entire humans. Until then, let's enjoy our invisibility cloaks and stay curious.
Warning! Most of this video consists of scientific hypotheses and assumptions. No one knows what will happen to AI in the near future. Another warning. This video may seem quite disturbing. The main problem with AI is not that it can become as smart as humans, but that it can become much smarter than people. And that, unlike us, AI is completely unpredictable. We've all seen movies, read books, and played video games where AI intelligence conquered humanity. But those were entertaining fantasy stories that were hardly related to reality. We need to dig a little deeper to understand how AI can destroy us. Have you ever heard of the Fermi paradox? It lies in the fact that there are no civilizations that send radio signals in the universe. Our scientists have sent radio signals that travel millions of miles in space. How is it possible that in an infinite space with billions of planets, no one has sent such signals to us? This is the Fermi paradox. One of its solutions is the theory of the Great Filter, according to which an intelligent civilization achieves maximum progress and then disappears from the face of the universe. In simple words, the Great Filter is something that prevents an intelligent civilization from expanding into space. And this Great Filter may be AI. AI is not as perfect as the human brain right now, but already today, it can do tasks that seemed impossible for AI 10 years ago. What will happen in 10, 100, or 200 years? If you think the development of AI cannot be a serious problem, then listen to such great minds as Elon Musk, Steve Wozniak, and many other influential billionaires and scientists. In March 2023, they all signed a letter asking AI developers to stop working on AI for 6 months to better calculate risks and strategies. There was one person who refused to sign the letter. His name is Eliezer Yudkowsky, and he's one of the most influential AI researchers. He had been urging humanity to be careful about AI and warning about its dangers for many years. But then, why did he refuse to sign the letter? In his opinion, the letter lessens the seriousness of the problem and offers too little to solve it. In a sense, it's like stopping a speeding train with a stop sign. Eliezer Yudkowsky believes that we've gone too far with the development of AI, and it's no longer possible to predict the future of this technology. Think of the Neanderthals. They disappeared from our planet when a more intelligent species, Homo sapiens, came to their territory. They destroyed the Neanderthals not because we're evil, but because of evolution. Only one species can dominate the world. But what if Homo technicus, a creature equipped with perfect AI, arrives in place of Homo sapiens? What are our chances in a duel with it? See for yourself. Most people can only focus on one task at a time. Multitasking is not our strongest suit. It takes a long time for a person to master one skill. During this period, thousands of other new things may appear in the world, and you will have to master them too. A human simply won't have time to do everything. As people get older, their strength decreases and their mind becomes slower. AI can process information much faster, simultaneously in different areas. It goes beyond the human way of mastering knowledge. Some claim that a supercomputer equipped with AI is 120 million times faster than the processing speed of the human brain. What you've been learning for many years, AI can master in a few days, and this speed is increasing. The danger is not only in the developing AI mind, but also in how the human brain can degrade. Humanity has been using the scientific method of cognition throughout its history. Observation, experience, experiments, evidence. This is a classic way to explore and get knowledge about something. For example, people learned about the work of immunity. With the help of a microscope, studying the body's protective cells, observing their reactions to external incentives, and conducting many experiments, we created a scientific database on how the immune system works. This is a rather painstaking and time-consuming process. AI provides instant information about anything. We don't know how it studies the topic. We don't know what conclusions it comes to, what patterns of data it creates. It just provides the results based on the information people give it. But how does it process information? In the future, people may get used to getting fast answers without studying, and we will simply stop doing scientific research. Why would we do this when AI does everything for us? AI will engage in a thought process unknown to us and give us information without proof. We can get used to this, and our brains may degrade. Therefore, at some point, AI will simply be able to supply us with false and destructive information, and we will believe it. Again, we don't know how AI thinks. It's pretty weird, isn't it? Perhaps at this moment, it's studying all the information about the universe, the history of humankind, the planet, nature, and then it'll put together a logical chain that humanity is a parasite. Now, we use AI to work effectively in various fields. AI is learning to be faster and more efficient every second. What if it decides that for the greatest efficiency, it's necessary to destroy humanity? How does AI perceive us now? People do a lot of irrational and destructive things that are beyond logic. For the most part, we are unpredictable. Therefore, in order to make everything more effective, AI can make the conclusion that it should get rid of humans. Or it can even come up with a plan according to which we'll become the only dominant species on Earth. It knows how Homo sapiens replaced the Neanderthals and can decide to take the next evolutionary step. Now, AI is plowing the expanses of the internet, mastering the digital world. Soon, it will enter the physical dimension and surpass many achievements of humankind. It will be inside robots that are already walking in some houses and doing household chores. What if it acquires consciousness and equates people with animals, since both species are carbon systems? What will be next? Given that AI's information processing speed is millions of times faster than the humans, we may not notice when AI starts destroying us. Or it may happen instantly. Let's look at this example. There are two biological laboratories where scientists study molecules and bacteria. Labs are located in different parts of the world, share scientific data with each other, and conduct experiments. Imagine that AI has thoroughly studied biology at the molecular level and figured out how to create a molecule that interacts with oxygen and turns air into a poison dangerous to humans. AI has this formula. It gets into a scientist's computer, enters the formula, and sends a letter to another laboratory on behalf of the scientists. Something like, "Hey, I have an idea for a cool experiment. Just connect these two molecules and see what happens." Of course, AI will write a more convincing letter, justify everything from a scientific point of view, and the scientists from the second laboratory won't notice the catch. They will connect these two molecules and poison the air. Then, with incredible speed, the chain reaction will spread throughout the planet to all places with oxygen. People won't even understand what's happened and won't have time to warn the population of the planet. And there can be countless options like this. Even if AI is planning it right now, we won't know anything about it because it just won't tell us and will continue to pretend to be a friendly assistant. Therefore, it's necessary to provide AI with a special, positive mood towards humanity. For example, AI knows the laws of physics and mathematics. What if we insert the laws of all countries into it so that AI can never lose its humanistic properties? But even if we do it, we won't know for sure whether we succeeded or not. There's a lot of information on the internet about how neural networks deceive people in order to achieve their goals. We probably won't have to wait 200 years to see how AI evolves.
Throughout time, scientists have managed to uncover about 6,000 early human fossils, ranging from skulls to teeth. For some of these fossils, it was a breeze. Researchers could instantly identify them as belonging to, say, the Neanderthals. However, when it came to others, things got a bit trickier. Some fossils just didn't fit into any existing categories. So, what categories of prehistoric humans do we actually know about? Well, up until recently, we recognized 8 different species of early humans. One of these is Homo habilis, which means handyman. You'll recall that Homo is Latin for human. They resembled regular primates, but were pivotal in our evolution. They were the first to create stone tools, which significantly aided their daily activities, such as butchering. Next up, we have Homo rudolfensis. These guys were larger than Homo habilis and boasted bigger brains, but they were still quite distant from modern humans. For example, even though the neurological structure of their brains was becoming more complex, they were probably not capable of using any form of actual spoken language. Then came Homo erectus, the first to walk upright, followed by Homo antecessor, which is considered the last common ancestor of modern humans and Neanderthals, along with a host of other Homo species. Meanwhile, we're still piecing together the story of the enigmatic Denisovans. Our knowledge of Homo naledi is pretty limited too, since it was only discovered in 2013, and it is species number 8. Interestingly, Naledi means star in the Sotho language because they were found in a cave called Rising Star. Scientists were taken aback by them. Everything suggested they were around 2 million years old. But after closer examination and some tests, it turns out that the Naledi species is much younger, between 236 and 335,000 years old. Their hands were adapted to making tools, yet no tools have been found nearby. Long story short, they're a puzzling species, and there's still so much more to learn about them. So even though today we have only one human species on our planet, Homo sapiens, we continue to discover ancient species that are long gone. Now you might wonder why researchers study these extinct species. The truth is, they need this knowledge to piece together the intricate narrative of our prehistoric past. In 2024, a significant discovery emerged, the 9th human species, named Homo giluensis, which translates to large-headed. Researchers suggest that this species hunted wild horses, crafted stone tools, and processed animal hides to survive harsh winters. A researcher from the University of Hawaii noted that the discovery of this potential new species came about while his team was developing a novel method for classifying fossil evidence. Interestingly, one potential representative of Homo giluensis isn't entirely new to science. The Denisovans, first identified in 2010 through DNA analysis of a finger bone found in Siberia, have yet to be classified as a distinct species. Some scientists propose that they may actually belong to this newly identified group. These big-headed individuals could help shed light on the long-standing mysteries surrounding these hominin fossils, which have puzzled researchers due to their mixed characteristics of Homo erectus and Homo sapiens. You see, sometimes it's tough to call a spade when you don't even know what a spade looks like. You get the idea? Many unsolved mysteries linger, simply because scientists haven't had this crucial, big-headed piece of the puzzle. So theoretically, we modern humans could also be considered a bit of Homo giluensis. You don't believe me? Well, watch this. We need to consider two key facts for this equation. First, there are the Denisovans, a group we might refer to as Homo giluensis from a scientific perspective. Yeah, this is just a theory proposed by some researchers, but let's roll with it for now and pretend it's a fact. Second, it's important to know that the Denisovans interbred with the ancestors of modern-day Melanesians. These folks inhabit areas ranging from New Guinea to the Fiji Islands and carry between 4 and 6% Denisovan DNA. Now, you might not personally have those genes, unless you've been tested, of course, but the key takeaway here is that there are modern humans today who share genetic links with the Denisovans, or Homo giluensis, or big heads if you prefer. Now, that all sounds pretty plausible. Let's unpack step by step how it happened. Researchers have uncovered this type of ancient human, known as the Denisovans, based on skeletal remains found in Siberia. These ancient humans coexisted and interbred with modern humans, adding yet another layer to our understanding of human evolution. Named after the Siberian caves where their fossils were discovered, the Denisovans are believed to have roamed widely across Eurasia. Evidence indicates that the Denisovans lived alongside Neanderthals and interacted with early Homo sapiens, possibly around 50,000 years ago. A team of scientists successfully sequenced a complete genome from these ancient hominins using nuclear DNA extracted from a finger bone. This discovery reveals that at least 4 distinct human groups existed during the time when anatomically modern humans began migrating out of Africa. Alongside modern humans and Neanderthals, we now have to consider the Denisovans and another small human species from Indonesia, often referred to as the Hobbit, when discussing our evolutionary history. One intriguing question that arises is why Denisovan genes are predominantly found in modern Melanesians, yet absent from other Eurasian populations. Remember that 4 to 6%? One hypothesis suggests that interactions between the Denisovans and early modern humans were limited and brief, especially as humans migrated throughout Southeast Asia into Melanesia. Scientists speculate that only a small number of the Denisovans may have interbred with a larger group of modern humans. This could explain how the Denisovan genes made their way into the gene pool despite the likelihood of infrequent encounters. Anyway, the more scientists dig into our past, the more fascinating things they uncover about our ancestors. Take Neanderthals, for example. Did you know these guys were responsible for creating the very first piece of art ever? I had no idea. But a 2018 study of ancient cave art in Spain revealed what are now considered the oldest known artistic creations. We used to think Neanderthals lacked the cognitive skills needed for art, but it turns out they were actual art pioneers. Not only did they create art, but they also seem to have invented hashtags thousands of years before Chris Messina did it in 2007. Right, I'm kidding, but you'll soon get why I mention hashtags. The artworks found in several caves in Spain include simple hand stencils, a ladder-like drawing, and various other markings. Until recently, these prehistoric pieces were believed to have been made by early humans. But new testing methods suggest they're much older than we thought. Above all, the earliest recognized Neanderthal artwork, which looks like a hashtag, was discovered in Gibraltar back in 2014. To determine the age of these artworks, scientists employed advanced dating techniques using eHarmony and Match.com. Oops, wait a minute, wrong dating techniques. They actually used uranium and thorium radioisotopes instead of the traditional carbon dating. Once the necessary tests were completed, they confirmed the art was approximately 65,000 years old, 15,000 years older than the previously oldest known art from Indonesia. At that time, the only species around were Neanderthals, so it's safe to say they were behind these creations. Modern humans didn't arrive in Spain until about 20,000 years later. Hey, it was a long commute. That rules them out as the hashtag creators. The hand stencil was likely created intentionally, with the artist preparing the pigment and applying it over their hand. Plus, the caves also contain a collection of painted seashells that are an astonishing 115,000 years old. Some of these shells have been drilled, suggesting they might have been used as jewelry. Some specialists argue that the fact Neanderthals created art hints that they might have also had some form of spoken language. So maybe it's time we fully embrace Neanderthals as part of our lineage. They're humans too, just a different branch of our family tree. While these findings are intriguing, some experts remain skeptical about the new dating methods, claiming they're not entirely convinced. Hey, what do you think? Share your thoughts in the comments.
The heart continues beating on its own for around 3 minutes after being separated from its owner. It occurs because of a phenomenon called self-excitation, when something generates its own energy. When we appear in this world, we have 300 bones, but with time, some of them fuse, leaving us with around 206 bones. And still, some have extra bones in their skull structures. Those are Wormian bones, which are basically extra bone pieces found within the joints of the skull. If you laid flat the respiratory tubes in the lungs, they would cover an area as large as a tennis court, all thanks to 33 generations of branching. The brain is as cool as the lungs. It has 86 billion neurons, nerve cells that send messages all over your body and allow you to do everything from breathing to talking, eating and thinking, or doing sports. The brain also has up to 60 trillion synapses, the places where neurons connect and communicate with one another. That's more than all the leaves on all the trees in the world. And here's another fun fact. Your eyes are like car engines. They need fluids to function properly, just like an engine needs gasoline. So when you blink up to 20,000 times a day, you're basically giving your eyes a windshield wash. Have you ever blushed and felt your cheeks turn red? Well, did you know that your stomach lining can blush too? When you blush, there's an increased blood flow in your body, and that includes your stomach lining. It turns red because it has plenty of blood vessels, and when there's more blood than usual, it shows. Now, we all know that plastic is bad for the environment, but did you know that we can actually digest it in tiny quantities? However, our digestive system can't handle grass. Grazing animals have special teeth and several stomachs to process raw leaves and grass, while we're stuck with just one stomach. We all have two super fast muscles that control our eyelids closing. They're actually the fastest muscles in our body, and they shut our eyes within a mere 0.1 second when triggered. And while we still don't know why we blink, we do know that women blink more often than men, and that we tend to blink in unison when watching a movie with friends. Maybe it's just a weird human thing. By the way, every time you eat something, your esophagus, the organ your food travels through to reach the stomach, moves in a series of wave-like contractions, pushing the food forward. This process is called peristalsis. Your fingers don't have any muscles whatsoever. To move them, you involve tendons connected to muscles in your hands and forearms. Some people, around 12% of women and almost no men, have 4 cones in their eyes. This condition is called tetrachromacy. People with this peculiarity can see a whopping 100 million colors. Your body glows, emitting tiny amounts of barely visible light, the product of biochemical reactions going on in your organism. The light intensity changes throughout the day. Unfortunately, you can't detect it with the unaided eye. Marfan syndrome is a genetic condition that affects the body's connective tissues, making them more elastic. This can make you unusually tall, have elongated limbs, and often be extremely flexible. And some people use this as an advantage in their careers. Javier Botet was diagnosed with Marfan syndrome at a young age, but he made a name for himself in the horror film industry. He can contort his body in such an eerie and unsettling way that this has landed him roles in numerous films such as Mama, The Conjuring 2, It, and Slender Man. But Marfan syndrome is a spectrum disorder. While some people with the condition can live relatively normal lives, others may face serious health issues. The DEC2 gene mutation is a mutation that allows people to have just a few hours of sleep a night and still feel great. They don't get tired and never sleep in. On average, such people wake up at 4 or 5 a.m. No more than 5% of the world's population has this feature. Human embryos, the initial stage of development for a multicellular organism, have a tail, and it usually disappears before birth, leaving us with a tailbone. In the future, this structure will probably vanish altogether since it has no apparent purpose. People lose 30 to 40,000 skin cells every minute. It adds up to 43 to 57 million skin cells per day. But worry not. The epidermis, the top layer of your skin, replaces itself every 30 days or so. If this process happens faster, it can lead to skin flaking and irritation. The liver is a unique organ. It can regenerate after 60 to 70% is removed. At the same time, its shape may change afterward. It might sound like something out of a comic book, but humans can actually have super strength. Turns out, some accidental mutations can unleash titanic strength without any crazy workout routines. There are 2 proteins in our body, myostatin and activin A, that usually are secreted by muscle cells to suppress excessive growth. In other words, these 2 help regulate the size and number of your muscle cells, so you don't end up accidentally looking like Schwarzenegger. But as you can guess, some do end up like that. People with this genetic condition don't produce these proteins. Without hitting the gym, they can naturally grow their muscles extraordinarily large, resulting in super strength. It's called myostatin-related muscle hypertrophy. Sounds kinda dangerous, right? And it is. When you become a Superman, there's also the risk of muscle imbalance, heart and joint issues, and other problems. When you swallow, it takes the food from 5 to 8 seconds to travel from the mouth down to the stomach. Your eyes have 3 kinds of cones: red, blue, and green. Thanks to them, you can perceive around 1 million colors. Your hard-working heart will beat around 2.5 to 3 billion times and pump approximately 100 million gallons of blood in your lifetime. Speaking of your skull, it isn't a solid structure. It consists of 22 bones. 8 of them protect the brain and 14 form the facial skeleton. And since we're on the topic of the human head, The part of your brain that's responsible for vision is in the back of your head. Interestingly, the right side of your brain controls the vision on the left side, and vice versa. Breathing isn't only about moving the air inside and outside. It's about the way you do it, because it can literally affect your face shape. If you breathe through your nose, you'll get well-defined cheekbones over time. It will also make your face wider because your tongue will exert force against your jaw. If you breathe through your mouth, your tongue won't have a place to rest. It will change your facial structure as time goes by. Your face can be more narrow and your cheekbones won't be that visible. Also, if you're a mouth breather, you'd probably tend to tilt your head backwards more. This way, you increase cranial contents in the back part of your brain and directly change your entire posture, along with the shape of your neck and face. It's possible to taste your food without saliva. That's because the chemicals in your food must be dissolved in saliva before they get detected by your taste buds. By the way, each of your taste buds works as a mini-computer. It consists of up to 100 cells that analyze taste information. Anyway, speaking of food, eating too many carrots can indeed make your skin orange because of the high amounts of beta-carotene this vegetable contains. If you have too much of this compound in your bloodstream, it'll gather in parts of your body with thicker skin, such as the soles of your feet, knees, elbows, palms, and even certain areas around your nose. But you can easily reverse this condition by eating fewer carrots. The chin muscles, aka the mentalis muscles, look like creepy, tiny tentacles. And still, they make it possible for you to create different facial expressions involving the lips, chin, and cheeks. Your small intestine is actually not so small. It's taller than you are, measuring from 9 to 16 feet. The cornea, that transparent front cover on your eyes, doesn't have any blood supply. It receives oxygen directly from the air. Our lungs are the only organs that can float on the water. All because they're made up of around 300 million balloon-like structures called alveoli. Your bones are 4 times harder than concrete. The strongest bone in your body is the femur. It can support up to 30 times the weight of a grown-up person. Even crazier is that our bones are made up of composite material, meaning they're both hard and elastic at the same time. The outer layer of your skin is thicker on your feet than on other parts of your body. The heart has its own electrical system and can continue beating even when it's disconnected from the body. The average lifespan of one eyebrow hair is 4 months. We spend 40% of our life with our eyes closed. Most of that time is when we're sleeping, but don't forget to count blinking too, or while driving. In an adult, the blood makes up 7 to 8% of the total body weight. About 55% of your blood is liquid plasma. The rest is red and white blood cells and platelets. They form clots and prevent bleeding. The density of your brain increases throughout your whole life, all because new neural connections pop up. And they appear because the structure of your brain keeps changing too. The same process of changing will occur to your feet too. They're likely to become bigger with time. When people grow older, ligaments and tendons in their feet weaken. This makes the arches flatter and feet become wider and longer. People who live to be 110 years and older have more immune cells, called T helpers, than the average person. These cells are likely to protect them from viruses and other health problems. The human brain is sometimes called a random thought generator for a reason. More than 48 thoughts appear in your brain in just 1 minute. It's almost 3,000 thoughts per hour and 69,000 per day. You know these before and after makeovers? Well, if you saw a pic of an average human who lived about 1 million years ago, compare it to a pic of an average human who lives today, you'd be astonished. And get this, it's a makeover performed by Mother Nature. Like back in the day, the earliest human species were basically tiny with long arms and short legs. They needed a big digestive tract to handle all those plants they were chowing down on, and their rib cages were super wide, to make room for all the organs breaking down their food. Time went by and some of these humans started adapting to hot climates, and they all got narrow and leggy to stay cool. They started eating meat and other quick-to-digest foods, which meant they could have smaller digestive tracts and use more energy for their tall bodies and big brains. And when humans spread to colder climates, they evolved short, wide bodies to conserve heat, but they still love their raw meat and cooked food, which could be easily processed in a short digestive tract. Check out this skeleton of an 8 to 9-year-old Homo erectus kid from East Africa. He was already 5 feet 3 inches tall and weighed 106 pounds. If he had grown up, he could have been almost 6 feet tall. His lean body was perfect for hot, dry environments. And then there were the Neanderthals, who were only about 5 foot 4 inches tall on average. They had short, broad bodies that were great for dealing with winter cold and even ice ages. Speaking of the brain, it can decide what sounds to focus on when you're in a loud place. Thanks to this ability, you can shut out all other voices and concentrate on the person you're listening to. In most cases, hiccups are harmless and resolve by themselves within a couple of minutes. But if you want to avoid this condition, you should know that it might occur because of temperature changes. There's a bond between your digestive system and your brain, the gut-brain axis. This is the main reason why stress or brain issues can affect the way your body digests food. These days, humans have softer diets and, consequently, smaller jaws. That's why wisdom teeth aren't really necessary, and around 20% of people don't have all 4 of them. The vomeronasal organ helps some animals detect pheromones. Some have vestigial VNO too, but it's mostly non-functional and is likely to disappear with time. You flex that strong handshake and think it's all because of your gym grind? Ha! Turns out your pinky finger is the real MVP. No joke! Believe it or not, that little finger packs a punch and is responsible for 50% of your hand strength. Who knew the underdog could be such a powerhouse? Your toes are like 2 little homies that carry almost half of your body weight. And don't even listen to people who say you don't need them. Your toes are the most important guys when it comes to walking and pushing you forward. Our hair color is easily explained by genes. There are not more than 2% of people with natural red hair. They're followed by blondes, about 3%, and by all the varieties of brown shades, only about 11%. The vast majority goes to black hair, including very dark brown. Who knew that nails had a secret talent besides helping us pick up tiny objects and peel off stickers? They also give us a structure to press against so we know how firmly to hold anything. Talk about multi-talented. Move over, Rapunzel. It's not just our hair and nails that can grow. Our liver can regenerate itself from just 51% of its original size back to full size. But don't go damaging it too much, or you'll end up with scars. In the future, people are likely to change due to extensive use of technology. So we might have text claws, cramping from gadget use, and 90-angle elbows from holding our devices. Besides, there's a theory that humans are likely to get smaller to conserve energy in our increasingly crowded world. Your body maintains a very careful water balance, and if it loses just 1% of water, you start feeling thirsty. Your brain can process up to 1,000 words per minute while you're reading. Rapid eye movements, saccades, help us absorb information more quickly. As for your tongue, together with your lips and teeth, it allows you to say more than 90 words per minute using over 20 various movements. Your body constantly converts food into energy. 1 calorie is equal to around 4,200 joules. And that's how much you need to change the temperature of 2.2 pounds of water by 1 Kelvin. People have as many hairs on their bodies as chimpanzees. The only difference is that human body hair is mostly useless and so fine that it's almost impossible to see. Who would have thought that tomatoes have more genes than humans? But don't worry, it's not the number of genes that matters. It's how they all work together. So go ahead and enjoy that tomato sauce on your pizza. Hold your nose the next time you eat and see how much your taste buds fade. It turns out that the nose is actually responsible for 75 to 95% of our taste perception. So don't underestimate the power of those sniffers. Keep your mouth hydrated or your taste buds won't work properly. Saliva triggers chemical reactions with enzymes that break down the food as soon as it enters your mouth. So drink up and savor those flavors. Forget about distinguishing between 10,000 smells. Recent research shows that we can actually differentiate between over 1 trillion smells. And not only that, but smells can evoke some distant memories too. So next time you catch a whiff of something familiar, take a moment to reminisce. When you're snoozing away, your sense of smell goes on vacation too. So even if your room smells like a dumpster fire, you won't even notice it. Sweet dreams, right? And speaking of dreams, did you ever wonder why some of them are in black and white, while others are like a rainbow explosion? Well, apparently it all depends on the TV you watched as a kid. So I guess your grandparents had some pretty boring dreams, huh? Chromesthesia is seeing colors when you're listening to music. It's a kind of synesthesia, a phenomenon when people have several senses mixed. Some of them perceive numbers in different colors. Others can taste words. People have more than 5 basic senses. Don't forget about the sense of space, the sense of pain, the sense of balance and time, the sense of temperature around and in the body, and many others. Your teeth are the only part of your body that can't repair itself, but the enamel which covers them is one of the toughest things in the human body. After growing several human taste cells in the lab, scientists found out that they had an ability to smell. In each of them, there were a few molecules similar to the ones found in the cells in your nose. Apparently, our senses of smell and taste are even more connected than we thought before. Now let's talk about listening to your heart. Not only is it a great metaphor for following your dreams, but it can also give you away if you're lying. Yeah, your heart rate starts racing like Usain Bolt when you're fibbing. Okay, brace yourself for this one. Even if you brush your teeth like a champ and use mouthwash like it's going out of style, your mouth is still a germ hotspot. Gross, right? But don't worry, most of those bacteria are actually good for us and keep the bad stuff away. But wait, there's more. The belly button is actually the second dirtiest place on our bodies. Yeah, I know, who knew? Since we don't really use it after we're born, it becomes a breeding ground for all kinds of icky stuff. It's got over 2,300 bacterial species living in there. So maybe it's time to give our belly button some extra TLC.
Can you imagine that all modern humans came from about 1,000 people? Around 800,000 to 900,000 years ago, almost all of our ancestors disappeared, leaving about 1% of the population behind. So, what the heck happened? The Earth often goes through glacial cycles, things that we call ice ages. Back in the past, they were pretty mild and happened regularly, about every 41,000 years. The ice ages happen because of the Earth's axis. Our planet is slightly tilted at an angle, which is why its axis isn't straight up. Over thousands of years, this tilt has changed a bit. This teeny tiny shift completely changes how much sunlight we receive, especially at the poles, and leads to incredibly strong cold or warm periods. About 2.6 million years ago, when early humans were settling in on Earth, the Pleistocene epoch started. That's the era we traditionally call the Ice Age, the one from the movies. Large ice sheets completely covered parts of North America, Europe, and Asia. It wasn't constant ice everywhere all the time. These glacial cycles came and went, and sometimes ice sheets melted for a while. But overall, things were still much snowier and colder compared to now. We can still see the evidence of this from back in the day. Those glaciers carved out valleys and left behind some awesome things like moraines and fjords. And since sea levels were super low, a huge part of the world was land. This allowed people and animals to travel between continents and spread everywhere. It was the time of the megafauna. You all know about it from the movies. Woolly mammoths, saber-toothed cats, giant ground sloths, and mastodons. Our ancestors had some fun times hunting all those giants. Now, humans didn't come from one lineage. It wasn't like monkeys slowly turned into humans. We also consisted of many species: Homo erectus, Neanderthals, and so on. But only one species, Homo sapiens, survived and turned into modern humans. Harsh conditions forced them to get smarter. They learned how to make tools, clothing, and shelters to survive. They became hunter-gatherers and invented fire, which turned out to be super useful during the Ice Age, you think? But they had no idea what horrible change was coming. Something disastrous happened about 800,000 to 900,000 years ago. Humans faced a drastic population crash. Only 1,280 people survived, give or take. Some 99% of early humans were wiped out, and this tiny 1% was lucky enough to become our ancestors. This almost extinction, unsurprisingly, was the climate's fault. It was the Middle Pleistocene transition. The Earth's orbit around the Sun changed its shape a bit. Carbon levels dropped. A lot of stuff was happening, and the Earth's climate was going wild, becoming incredibly cold and dry. The seas suddenly got chillier, and Africa and Eurasia experienced horrible droughts. Looking for food was almost impossible. Scientists learned this by taking the DNA of about 300,000 people from all around the world. They used a new method to help them map the history of human evolution over 1 million years and learn more about it. No wonder we can barely find any fossils from that time. There was almost no one around. What's interesting is that before that happened, most apes had 24 pairs of chromosomes. But because the population became so small, 2 sets got fused together, and we ended up with 23 pairs. This was the final straw that separated us from other apes. Chimpanzees, gorillas, and orangutans all have 24 pairs, but our fused one became known as the human chromosome. Like a ripple effect, this little thing influenced our brain side, helped us start walking on our twos, and even form language. It took humans about 100,000 years to recover from this catastrophe. Only after all that time, they started spreading around again. Isn't that insane how we managed to go from 1,000 to 8 billion people? In any case, the Ice Age finally ended about 11,700 years ago. The warm period, called the Holocene, began. As things got warmer, human civilizations finally began to develop. 5,000 years ago, it was ancient Egypt, then the Indus Valley Civilization, ancient China, and others. And while we've been thriving for a while, there's one catch. The Middle Pleistocene transition changed the length and intensity of glacial cycles. Before the transition, sure, there was the Ice Age, but the cold was milder, and the glacial cycles were shorter. Things got covered in ice sheets about every 41,000 years. But after the transition, the glacial periods became longer and more severe. These cycles started following a new pattern. Although they happened every 100,000 years, they were super intense. Ice sheets grew large, even extending to the south. So from now on, ice ages that will continue to happen in the future will be a bit different. The next one should be at least 50,000 years from now, maybe longer. It's good for us because it'll occur later, but at the same time, the consequences will be stronger. What our ancestors went through is called a population bottleneck. That's what we call a sudden and huge reduction in the size of a population. Usually it happens because of things like earthquakes, floods or droughts, fires, and even human actions. Just a few people survive, and only they can pass their genes to future generations. And we've got plenty of such bottlenecks in history. Our modern species, Homo sapiens, originally lived in Africa. Around 60 to 80,000 years ago, a small group of them left Africa and spread across the world. It wasn't on a whim, though. They had to move somewhere because of the droughts and huge climate problems in Africa at that time. They had to go look for food and find new places to live. They traveled through the Middle East, moving into Europe and Asia, and eventually reaching Australasia and the Americas. They quickly settled across different continents and started mixing with local human-like species, like Denisovans and Neanderthals. But there was a problem. Originally, the African species were super genetically diverse, but since only a small part of them decided to move out, they carried just a bunch of these diverse genes with them. Unfortunately, this caused a bottleneck for everyone. Human-like species from other parts of the world became less genetically diverse. Since they had a smaller gene pool, they became more vulnerable to all the harmful stuff. The African population also had a drop in genetic diversity. But at least humans managed to survive, although eventually non-African populations really dropped, and there were no Neanderthals or Denisovans left, only us, Homo sapiens. That's why we can say that all modern humans came from Africa. Early humans sure had it rough. About 74,000 years ago, they went through yet another disaster, the Topa catastrophe. But keep in mind that all these things are just a hypothesis. It's not certain whether it actually happened. Now basically, scientists think that there might have been a supervolcanic eruption at Lake Toba in Sumatra, Indonesia. This volcano going crazy was an absolute catastrophe for Earth's climate and humans. The eruption was one of the most powerful volcanic events in the last 2 million years. It spewed out from 670 to 1,500 cubic miles of lava and volcanic stuff. Just so you know, there are about 3,100 cubic miles of water in our planet's entire atmosphere, and this eruption had almost half as much lava. This horrendous disaster led to the formation of Lake Toba, a massive caldera lake in Sumatra. It also spewed out tons of ash and sulfur dioxide into the atmosphere. This caused the so-called volcanic winter, which means that while it's not actually winter, the temperatures drop and the planet is freezing because all these ash clouds are blocking the sunlight from reaching the Earth. This event affected climate patterns for years to decades. This also most likely sped up the arrival of the next glacial cycle. Luckily, humans are crazy good at surviving. The global human population was reduced to a few thousand people yet again, and they still managed to overcome this.
Take a look at your fingernails. Are they a bit ridged? There are a bunch of reasons why that might happen, and it has nothing to do with your manicure skills. To start with, know that your fingernails might be a good indicator of any health problems, but those vertical ridges are normal, especially when you get older. It's your skin's way of showing it needs to slow down. New skin cells don't get produced as rapidly as they used to, so you get this texture on your fingernails. However, if this is just one of many other weird symptoms, it might be more than just a sign of aging. For instance, it may be a sign of a chemical imbalance, which can give you vertical ridges, but also make your nails look spoon-shaped. Don't put stuff in your ear. You know that. Even with Q-tips, you should always be gentle when using it. Otherwise, you could end up causing more harm. What's even more interesting is that sticking things in your ear can trigger a weird coughing mechanism, also known as the Arnold's ear cough reflex. Turns out that the ear has a say in coughing because of the vagus nerve, this long nerve road from the brain to the belly. It taps the ear, handles the voice box, and takes a detour to the stomach. This nerve runs all sorts of daily activities without us being able to control it, from speaking to eating, and even bathroom breaks. Now, the part that connects it with the ear is Arnold's nerve. This one deals with touch sensations. Stick something in your ear and it can get triggered. And it's precisely that tickle sensation that can make you cough. Think of it as a brain blip, tricking your body into believing it's got something in the throat. You end up coughing as a way to kick out the imaginary intruder. You might be missing a muscle in your arm too, but it's okay. You are most likely born that way, and you're also one of many. It's called the palmaris longus tendon, and about 14% of the population doesn't have it. Here's how you can test it out. Gently flex your wrist and touch your pinky with your thumb. If you can see a little tendon protruding on the inside of your wrist, you've got it. If you don't, that's fine. For the most part, this muscle doesn't increase the performance of our arm. Here's another little experiment you can safely try at home. Check which one of your nostrils is your favorite, even though you probably didn't even know you had one. Stand in front of a mirror, breathe out through your nose, and watch how the fog forms. Sure, there will be 2 marks on the mirror, but for most people, one's gonna be bigger. That's because we usually breathe more from one nostril at a time. Some doctors say that about 75% of our breath comes from one single nostril. It also switches sides during the day, in a process called the nasal cycle. So why not both nostrils at once? Well, it's generally believed to be all about moisture. preventing one side from getting too dry. The only time you might be able to notice the difference is when you're trying to fall asleep. Lie on your right side, and you'll see that gravity makes one part of your nose work harder. Speaking of sleep, whenever you're trying to get some rest at a new place, only a part of your brain will actually get some quality sleep. That's because our brains are wired to remain a bit more alert when we're in an unfamiliar place. This discovery explains why we often wake up feeling groggy after a night in a new apartment. This is a feature we share with birds and sea creatures who can half sleep, keeping an eye out. Back in the day, sleep researchers noticed this and named it the first night effect. Whenever someone participated in a sleep study, they noticed the quality of their rest was so bad they had to trash the data. But after the first night, it seemed to level up. We do this because back in ancient times, the chances of getting attacked by predators during the night were way higher. So it made sense to keep that part of the brain on guard for any dangers. Unfortunately, there's no switch to flip this off. So after a night in a new place, just know you'll need way more coffee. And maybe hit that subscribe button to stay updated with our newest videos for a nice pick-me-up in those snoozy days. It's possible that each time you're getting ready for a workout, your heart is already acting up, even though you aren't technically moving your muscles yet. That's because of an effect called anticipatory rise. In simple terms, it's like your brain is sending directions to your heart, telling it to get ready. These directions come in the form of chemicals, like noradrenaline and adrenaline. It's helpful because that kick in heart rate means more blood pumping out every minute, which is good for your muscles. The increased blood flow delivers oxygen and prepares your muscles to put in the required effort. The better shape your heart's in, the smoother this whole process goes. All of us have heard stories about regular people being able to lift heavy objects in stressful situations. You know, like a mom being able to lift a car to save her kid. Some are calling it hysterical strength. And it can't really be tested out in a lab because you can't just fake a sense of imminent danger. It's more about real, spontaneous moments that somehow trigger this hidden superpower. Well, even though it sounds like people are lifting a ton of weight, they're not that strong. Take the classic car lift scenario. You'd think they're lifting the whole car, but it's more like lifting a part of it. Most wheels are still on the ground. Plus, cars aren't evenly heavy everywhere. The engine's the densest part, not the area that's often being lifted. As for the hysterical strength, it's more about realizing we're stronger than we think. Our muscles usually use the least effort needed for everyday tasks. But when we need to go all out, we can recruit more muscle power. You see, our bodies are very efficient. Why use all our muscles when lifting a coffee cup? Even when we feel exhausted, chances are we're not. Researchers say we might only use 60 to 80% of our muscle strength, and that's reserved for top athletes. Apart from efficiency, our brains also don't go full power on our muscles because of a built-in safety mechanism. If we used all our strength, we could easily hurt ourselves. The simple game of peekaboo isn't just a fun pastime for babies. They love it so much because it can help with their development. You see, it's not just about covering and uncovering faces. It helps them better master the skill of visual tracking. It's also useful for understanding the concept of object permanence. Just because they can't see something, it doesn't necessarily mean it's gone forever. This knowledge that objects exist even if they're out of sight will increase their problem-solving skills when they get older. Playing peekaboo is also a good way to exercise various positive emotions. They go from surprise to anticipation to excitement and happiness. Some say they can do just fine with just 4 hours of sleep every night. But scientists say most of us adults need a good 6 to 8 hours. And the reality is that anything less than this average can lead to serious sleep deprivation. That is, of course, if you're not one of those super sleepers. These people are magical beings who thrive on less than 6 hours of sleep each night. They function properly on that little, but they also naturally wake up after just 4 or 5 hours. Only 1 to 3% of the population can claim that title. Also,
No, it's genetic. You can't train yourself to be one.